Hey guys, hopefully you just completed the video analysis lab, and what we're going to do now is take a look at the results. As you finished, you probably saw a graph that looks something like this. It might have had y and x on there at the same time, but what we're going to do now is look at what each one of those means. So I'm going over here to the y-axis and I'm going to select y, which is what we're at now. And what this is telling us is that as you hit these points over here and kept track of the ball, Logger Pro just put a grid over this, and it said, down here at this corner is 0, or however it measured it. And now it's keeping track of the y coordinate. Each one of these points has an x and y coordinate, just like if you were graphing this in math class. And Logger Pro is now keeping track of the y coordinate for us, and it knows the amount of time between each one of these clicks from the frame rate of the video. And so what we can see is now the height of the ball at any given time. And we can see that when we trace out this y position versus time graph, it looks almost exactly like this one, even though this is x position as opposed to time. Now, what does all this mean? Well, if this is tracking how high the ball is versus time, we can almost think of this as motion. If you were to squeeze this so that the ball was just going straight up and down, this graph would tell us everything we wanted to know about its motion. If we choose to analyze this, and you can probably see a bit of that menu where it's sneaking down into my screen capture area, and select Curve Fit, and we want to do a quadratic, so we'll try that and select it. And we look at our data. We have this equation of y equals at squared plus bt plus c. And now I want you to think of this. Think back to your kinematics equations and see if this looks familiar, but more in a form of c being the displacement, b being the initial velocity, t being time, and a being the acceleration. But there's a factor missing in there. 1/2 at squared is our kinematics equation. So whatever value for a we have here is half the acceleration. And if we were to double a, you could see that that would be very, very close to 9.8 meters per second squared, which means that for the y part of this motion, for the up and down motion of the ball, it's accelerating at 9.8 meters per second squared, which is just what we'd expect from gravity acting on it. So we know there's acceleration in the y direction. It's accelerating because of gravity, and it's accelerating downward at 9.8 meters per second squared. Now let's look at the x direction. In the x direction, we just have a straight line. We can go ahead and do a linear fit and find the equation for this. And remember that this is a position versus time graph, so the slope of this line is just the speed. And notice that the slope doesn't change. This object, this basketball, traveled at the same speed along the x direction. So what we're seeing here is that when you have projectile motion, that is, this ball moves in that characteristic arch, that parabola that we come to associate with any thrown object on the surface of the earth, that in the x direction, left and right, it just moves with a constant speed, whatever speed it was thrown left or right in the beginning. So if I want to figure out how far it's going to go left and right, I can use our constant velocity model. It works because we don't have to worry about the acceleration. The acceleration is only happening, we only get this curve in the y direction. So in our y direction, the ball is accelerating, but in the x direction, it's not. And this is key to analyzing situations involving projectile motion or any kind of two-dimensional motion like that, is that you can think of each direction as being its own separate motion. So the up and down, the y-axis motion of this basketball has no effect on the x-axis motion of this ball. They're completely separate. So while gravity acts on the y component of this, the up and down portion, it has nothing to do with the x component. And that makes these problems really easy to solve once you get down to it. And that'll be the next thing that we look at.